Hey everybody, this is Mr. Lowry, and we are on angles of triangles. Today in class we proved two theorems about triangles. One of them was called the angle sum theorem, and the other was called the exterior angles theorem. Now you can find these in your textbook. The angle sum theorem is on page 185. It's also called theorem 4.1 in your textbook. And then the exterior angle theorem is on page 186. It's also called theorem 4.3. So this was theorem 4.1 on page 185. And this guy down here is theorem 4.3 on page 186. Okay. Now if you're in class today, we proved those theorems in class. And now you're going to apply them. If you weren't in class today, then what you should do is you should go back to the notes post for today and kind of go through those proofs so that you understand where they come from. That is not up yet, but it will be up later this afternoon. So if you're at home and working on this, I would check back later. Make sure you can go through those proofs first before you start this one. All right, now, their directions of these different problem sets are kind of long, but the reason why they're long is because there's some details in there that I want you to know about. So it says apply the angle sum theorem. Okay, well, first of all, you got to know what the angle sum theorem is. Okay, let's look it up. If you didn't know, angle sum theorem says the sum of the measures of the angles of a triangle is 180. Okay, that's true for every triangle. So when you look at this triangle, what you know is the sum of the measures of the angles are 180, and that's true for all of these triangles. Okay, so you're going to use or apply the angle sum theorem to set up and solve an equation for x. So the setup would be that all the angles together, 75 degrees, 7x minus 7, negative 9 plus 4x, all are going to add to 180 when you put them together. Now, of course, there's some negatives in here because of the way it's written, so it doesn't all look like it's addition. It's more of kind of like a combine like terms. If you combine basically all those angle measures, you're going to get 180. All right, so you're going to solve it for x. Okay, that's the next step. Set up an equation and solve for x. So in this case, we're going to want to combine those like terms. We got 11x here. Then we got a 75, a minus 7, and a minus 9. Or that's, in other words, that's 75 and then a negative 16. Okay, so that's going to come out to, I believe, negative 59. But I'm going to double check so I don't lead you astray here. So I got 75. We're going to subtract 9 or add a negative 9, subtract 7 or add a negative 7. Yep, that's going to give us 59, positive 59. Okay. All right, now to solve this equation, we need to get x by itself. So we're going to subtract 59 from both sides. That's going to give us 11x equals 121. Okay. Now we're going to divide both sides by 11, and that's going to give us x is equal to 11. Okay. So we applied the angle sum theorem, check. We set up the equation, we solved for x, okay? Now the next part says plug the value of x back into the expression to find the measure of angle A. So here's angle A, and that's what it's asking us to find. We want to find the measure of angle A in all of these, okay? So negative 9 plus 4 times 11, that's going to be negative 9 plus 44, which is going to give us I think 35. Okay. So final answer, the measure of angle A is equal to 35. Okay, now I showed my work here, and it's, you know, it's not like a proof. You don't have to do a proof here. It's relatively organized, right? I got the first equation, simplify the expression on the left-hand side, solve for x, right? And then I got over here, I plugged it back in, I showed my steps there. So it's not a proof, and you don't have to have like super organized, you know, like number 1, number 2, number 3, number 4. But this, to me, is like organized enough where if I were looking at your paper, I could follow, okay, they're solving for x, they plugged it back in, cool. So that's what I'm looking for on these as well. I want to see that work in organized steps. Again, it doesn't have to be like a proof. You don't have to number your steps or anything, but I should be able to see your kind of your flow of logic there. Okay. Now 2, 3, and 4 are going to be all the same kind of idea. In 2 and 3, notice that you have this symbol, so that's going to be 90 degrees. It's a right angle symbol, right? But the idea for all of these is you're going to add up all the angle measures and set them equal to 180, solve for x, plug x back in. So reading the instructions very thoroughly in this case will give you kind of the steps that you need to do to take them. Sorry, to solve the equation. So I recommend doing that. Okay, now down here, we're going to basically be doing a similar thing. The difference, though, is that we're using a different theorem. Okay, so this one is going to be talking about the exterior angles theorem. So for reference, here it is in your book. I'm going to focus here for you. Okay. So what it says is the measure of an exterior angle of a triangle is equal to the sum of the measures of the two remote interior. Well, we define those terms in class, and if you're not sure what those are right here. Again, in your textbook, you got the definition of exterior angle and remote interior. But the idea here is when you take a triangle and you extend any side of that triangle, in this case they extended the bottom, you get a new angle. That angle is formed by the extended side of the triangle and the other side that it touches. So this is called an exterior angle here. Okay? The remote interior angles for that exterior angle are the ones that are not adjacent, right? So there's this little tiny triangle angle in here that's adjacent to number 1. That's one of the angles of the triangle. These are the other two. That angle is not remote interior. These two are. Okay? So this angle right here is one of the angles of the triangle. They didn't label it because we don't need to. This angle out here is not the angle of a triangle. It's just what's called an exterior angle. It's outside the triangle. But the measure of this outside or exterior angle is equal to the measure of these two, what we call remote interior. So it's the two angles of the triangle that aren't touching the exterior angle. That's what remote means. It means like removed or separated, and they're inside the triangle. Okay, so that's what the theorem says. Now we proved that in class, and so if you missed class today, you're going to want to go back and go through that proof. Make sure you understand that proof, which will be posted in the video post. Sorry, I'm going to make a notes post and post a video of that. But you can also find that proof in your textbook right here as well, if you want that for reference, okay, which is on the next page. So we start with definitions, right? Exterior angle definition, remote interior angle definition. Then we get a theorem, which is a fact about the relationship between those terms, those types of angles. And now in the homework, finally we apply that idea. Okay? So the exterior angle theorem says, for an exterior angle like this one, the measure of this exterior angle is equal to the sum of its two remote interior angles. Okay? So again, it's not this angle. We're not worried about this angle of the triangle. We don't care. We're talking about this outside angle and the two inside angles that are not adjacent to that outside angle. Okay? The exterior angle is equal to the sum of the two remote interior angles. So that's my setup, right? I'm going to set up an equation using that exterior angle theorem. Okay? Apply the exterior angle theorem to set up an equation. Okay, now we got to solve for x. So we got some stuff on the right that we can simplify. I'm going to make this 8x plus 82 now. Okay. We need to group the x's, so I'm going to subtract 8x from both sides here. That's going to give me 5 plus 11x equals 82. Okay, now I'm going to subtract 5 from both sides. That's going to give me 11x equals 77. Okay, and I'm going to divide both sides by 11, and so now I know x is equal to 7. Okay, so I'm showing my work kind of in organized steps, right, just line by line by line, until I get down to x equals 7. Okay, so now I'm going to take that, and I'm going to plug it in. So plug in the value of x back into the expression to find the measure of the angle indicated. Okay, we want YBC. YBC. That's this angle, this exterior angle. Okay, so what I would do here, I'm going to go off to the side. I'm going to say that angle, 5 plus 19x, I'm going to rewrite the expression, except I'm going to substitute 7 in for x. Okay, so that's 5 plus 133. Nope, not even close. Wait, maybe I was. Hold on. Times 7. Ah, it is 133. I was right. Cool. All right, so 5 plus 133, that's going to give you 138. And so the measure of that angle we were looking for, again, that was YBC, is equal to 138 degrees. Okay? Now, not a proof, right? You don't have to do a proof. I do want to see your work in kind of an organized flow. And what I mean by that is, like, you know, sometimes people do like scratch work and it's like all over the place, right? This isn't super organized, but this is good enough for me. So you got the equation, you're solving the equation, that's what I'm looking for. You got x, I'm looking for another spot where you plug that 7 back in and you get the measure of the angle you're looking for. That way, if I can see that, I know that you know what you're doing. So 6, 7, and 8 are very similar to that. Just to clarify here, on number 7, this angle is this measurement is referring to this guy. When the software is trying to like generate these problems, it can't write 5x minus 5 like really tiny, and so it automatically just puts it as close to the angle as possible. So this guy, this angle is this measurement. So just kind of be aware of that. Same thing here. This 4x plus 2 is referring to angle B. Basically whatever it's closest to, but again, that's sometimes kind of hard. All right, so that's your first little section. You have one example from each of those. So after the first example, the setup is just really similar, and you can kind of go from there. In the next video, we'll do an example from 9 and 10, and then we'll go through the proof of this third angle theorem. What you should do first is you should look up that theorem and try to prove it on your own, but if you need some extra help with that, you can tune back in and check that out. Thanks for watching.